All right, class. So talking about Hpg pathway, what does these letters stand for? H stands for hypothalamus, P stands for pituitary, and T stands for thyroid gland. So this is really important for us to understand. And once we understand this pathway, we can apply it to other hormonal pathways as well. And if you notice, the stimuli is hormonal in nature here. Okay, so talking about the Hpg pathway, we do see the hypothalamus. The hypothalamus works as sensor, integrator, and effector. And the hypothalamus releases a releasing hormone called thyrotropin releasing hormone, or TRH. The TRH is transported via blood, specifically the hypothalamo-hypophyseal portal vessel, and targets the anterior pituitary. In response to TRH, the anterior pituitary releases TSH, or thyroid stimulating hormone, which stimulates the thyroid gland to produce thyroxine. When there is appropriate or enough of thyroxine in the blood, that tells the anterior pituitary, that also tells the hypothalamus, hi there is enough thyroxine in the blood, so you guys can relax. Therefore, the anterior pituitary and the hypothalamus then knows that, okay, we don't have to worry about thyroxine now because there is enough of thyroxine in the blood. So we can just sit back and relax for now. Okay, so we see a classic negative feedback inhibition loop here. Okay, now we will start looking at things in a little different way now. Now, we understand the feedback loop, right? Hypothalamus releasing TRH, which then targets the anterior pituitary. In response, the anterior pituitary releases TSH, which targets the thyroid gland and causes the thyroid gland to release thyroxine. When we have enough thyroxine, when we have enough thyroxine, that inhibits further release of TSH or TRH from the anterior pituitary and hypothalamus respectively. We understand this. But do you think that the hypothalamus or the pituitary gland or the thyroid gland has eyes, nose, ears, or fingers to know how much hormone it's releasing, if any at all? How does it even know when to stop secreting? So to understand that, we have to know and we have to understand that these glands have receptors. The hypothalamus has receptors for its own hormone TRH. Some of these hormones, when released into the bloodstream, travels all over the body, and it will come back full circle and ultimately bind to receptors in the hypothalamus. The more receptors bound to its own TRH, that tells the hypothalamus, oh, what a good gland am I. I have sent a signal. Let's hold tight and see if the downstream endocrine glands listen to me. Same thing happens to the anterior pituitary. Okay, so what exactly happens here? Some of the TSH, which are being released from the anterior pituitary, also populates receptors found on the hypothalamus. That way, the hypothalamus knows that the anterior pituitary received the signal, which is TRH in this case, and obeyed the signal by releasing TSH. Remember, the ultimate goal is to get the thyroid gland release thyroid hormone or thyroxine. And in turn, this hormone can feed back and populate receptors on all of the upstream glands, even itself. the population of these receptors by these hormones is the only way that the endocrine gland can detect levels of these hormones in the bloodstream. So we need to talk about this some more. In other words, there is this long feedback loop. So I will go to the next. Okay, so hypothalamus releasing TRH that targets the anterior pituitary. Anterior pituitary releases TSH targeting thyroid gland. Thyroid gland produces thyroid hormone that target other cells of the body. Okay, so when we have enough of thyroid hormone, it inhibits the thyroid gland. It can also inhibit the anterior pituitary. It can also inhibit the hypothalamus, right? So these are inhibitions. So what do we see here? We see that there are these long feedback loops, and ultimately so we see these long feedback loops here, and all these feedback loops are appropriately called negative feedback inhibition. If there is negative feedback inhibition failure, that leads to disease state. Do you agree? And so these are very long feedback loops or negative feedback inhibition loops that we see. There can also be smaller feedback loops. For example, when we have TSH can, enough of TSH tells the anterior pituitary, okay, stop now. Enough of TRH can also tell the hypothalamus, okay, stop now. And then TSH can also talk to the hypothalamus. So we see these long feedback loops, long negative feedback loops, and then short negative feedback loops as well. Okay? All right. And as I mentioned, disruption of these, if there is a disruption of these feedback loops, that can lead to disease states. All right. So maybe this is a new way of thinking about the endocrine system, but I would like you to think of what happens to hormone levels when thyroid function is impaired by either too much or too little activity. Let's start with an easy disruption in this pathway. And let's say we have an over-secreting tumor in the thyroid gland, over-secreting tumor. So tell me, what would be the level of thyroid hormone in a patient with this situation? Would thyroid hormone be normal, lower than normal, or higher than normal? Yes, it would be higher than normal. And if we have a lot of thyroid hormone, the thyroid hormone will populate receptors on the thyroid gland. It will populate receptors on the anterior pituitary, and it will populate receptors on the hypothalamus. Okay? And although these glands are getting the signal that, okay, we have enough thyroid hormone, but remember, there is a problem in the thyroid gland. So the thyroid gland will keep secreting. The thyroid gland will keep secreting more and more thyroid hormone, even though we have less TRH and less TSH in blood, because we have a problem. We have a problem in the thyroid gland. There is a tumor that's causing the thyroid gland to over-secrete. Okay? Now, what will happen if there is Okay, let me erase this. Okay, what will happen if we have an underactive thyroid gland? So in case we have an under secreting thyroid gland, we will have less thyroid, we will have less thyroid hormone, right? If we have less thyroid hormone, it will not populate the thyroid gland or the anterior pituitary or the hypothalamus. So the hypothalamus will think, there is less thyroid hormone. Maybe I should produce more TRH. And the anterior pituitary, receiving more TRH, thinks, I have a lot of TRH, so I should produce more TSH. And the more TSH affects thyroid gland, but remember, the thyroid gland is having some problem. It cannot produce enough thyroid hormone. So in this case, we have a hyposecreting thyroid gland or under-secreting thyroid gland. And obviously, this is also a disruption in the regular negative feedback inhibition loop. Okay. I want you to think about situations about what can happen if the problem lies in the anterior pituitary, or what am I doing? Oops. Let me erase all this. Or what can happen if there is problem with the hypothalamus? Class, the main point here, I want you to understand. If we have too much of thyroid hormone, if we have too much of thyroid hormone or too little of thyroid hormone, that does not necessarily mean that we have a problem in the thyroid gland. We can actually have problem in the anterior pituitary or hypothalamus as well, right? So let's say we have very little thyroid hormone. That can actually result from a problem in the hypothalamus. If we have low TRH, that will have low so that will impact to produce less TSH, and therefore we will have less thyroid hormone. So that is the main point. If we have more or less thyroid hormone, that does not necessarily mean it's a problem with the thyroid gland. It can be problem with upstream glands as well. Okay. Now, can we apply the same concept to Hpg pathway? Yes, we can. Hpg pathway refers to the hypothalamus, pituitary, and gonads. Same concept, the hypothalamus acts as a sensor integrator and effector and releases GnRH or gonadotropin releasing hormone. This targets the anterior pituitary, and in response, the anterior pituitary releases FSH and LH, which works on the gonads to produce sex steroid hormones, specifically estrogen and androgens. And when we have enough of the sex steroid hormones, estrogen and androgens, they tell the anterior pituitary, and they also tell the hypothalamus to stop producing more FSH and LH via negative feedback loop. So when we have enough of the sex steroid hormones, that signals the anterior pituitary and the hypothalamus to stop releasing more GnRH or more FSH and LH. I'll stop here and start with a new video.